Okay, so we're in Chapter 9, Section 3. And we're going to start off doing problems 7 through 10, which all relate to this one triangle that's in the book. So let me go ahead and draw the triangle. So it's an isosceles triangle. And it looks something like that. And we have the designation of A, B, C, and point D here. So because it's an isosceles triangle, we know that these two sides are equal to each other. We also know that these two angles are equal to each other. So problem number 7 asks us if B is 46 degrees, then angle A measures what and angle C measures what. Well, we know that A and C are equal to each other. So we'll just call that, let's just call it theta. So that's the angle, value of the angle. So we know that the angle, the measure of the angle B, which is given plus theta, has to equal 180, because those are all internal to the triangle. And so we would get 2 theta is equal to 180 minus B, angle B. And so theta is equal to 180 minus angle B divided by 2. So we just plug those in, and we have 180 minus B, which is 46 degrees divided by 2. If we plug those into our calculators, I can find my calculator. So basically what happens is angle B, we take 180, we subtract 46 from it, and that has to be evenly split between the other two angles because it's an isosceles triangle. And so we get 67 degrees. So we know that angle A is 67 and angle C is 67. Okay, number 8. If angle C measures 52, what is the angle of measure B? Well, angle C equals angle A, equals 52 degrees. And we know that angle A plus angle B plus angle C equals 180. So if we plug in 52 plus angle B plus 52 is equal to 180. That's angle B plus 104 is equal to 180. If we subtract 104 from both sides, we get 180 minus 104, which is 76 degrees. Okay, number 10. What is the, oh, actually number 9, sorry. Number 9. What is the measure of angle BCD if angle B measures 40? Okay, so this is BCD, is this exterior angle. So we know that this plus that is equal to that. So the question is, what is, if we can figure out theta, then we can figure out the external angle by dividing theta plus B. So the first thing we're going to do is figure out what, so we'll call it theta again. We can just use this equation. So theta is equal to 180 minus angle B, which in this case is 40, not 46. And we divide by 2, so that gives us 140 divided by 2, which is 70. Okay, so this angle is 70. This angle is 40. So we know that angle BCD is going to have to be equal to angle B plus theta. This is angle B and this is theta. So angle B was 40, theta was 70. So the sum of those two have to be 110. Okay, so that's right. Got the wrong thing in there. I thought I got it wrong. It's like, ah. Okay, number 10. What is the measure of angle B if BCD measures 100? So it's kind of going backwards. If this is 100, if this is 100, well, we don't actually have to. If this is 100, then this has to be 80 because they have to add up to 180 because there's supplementary angles. So we know that theta is equal to 80. Just write that down. So what we did is we took 180, subtracted angle BCD. Angle BCD is 100, I think. Yep, 100. So that's equal to 80. Now we know that theta here is also 80, so we add those two together. So 2 theta is equal to 160. So if this is 160, that just leaves 20 left over there because these three have to add up to 180. So we know from that, therefore, angle B is equal to 20 degrees. Okay, we're moving on to the next group. Name the corresponding angles and the corresponding sides for each of the following pairs of similar triangles. So similar triangles, basically everything, the angles are the same and the sides are ratioed. So it's just a bigger or smaller version where everything is scaled the same amount. So if we look at the triangles in the book, you can see they're oriented the same. So the lower left-hand corner is angle A for the bigger one, and that's equal to the lower left angle for the second triangle. Likewise, angle B, which is the upper corner, corresponds with angle Q, and angle C corresponds with angle R. So those are the three corresponding angles, and they're actually equal to each other. In the case of here, the second part is the line segments. And so the side AB, so it's the line segment AB, and the line segment PQ are the corresponding sides. Side BC or CB, doesn't matter which one direction it's in. So let's say side, I keep saying side BC, and I keep writing down C. Side BC in the left triangle corresponds to QR, and likewise AC in the big triangle corresponds with the line segment PR. So here the angles are equal. These are just if we took the ratio of these, this ratio of these, this to that, and this to that, and this to that would be a constant. Would be all the same constant scaling factor. Okay, now number 16 is a little bit different because we have these two triangles that are kind of connected. So I'm going to try to draw this. So it's like this, the bow tie goes over here. It's got a lopsided bow tie. Okay, so one thing we know is that these two are vertical angles, so they're going to be the same. And these kind of switch sides if you think about it. So this angle here actually corresponds to this angle over here. You kind of tell by if you drew parallel lines and transversals, you'd see that those are the same. And likewise, this angle corresponds to this angle. Let me go ahead and write the letters into E, A, B, C, D. So let me just use a different color because these angles, we have this angle, you'd find the corresponding ones here, and those sides would be, they're not equal really. I'm going to use the equal sign, but I'm really just trying to show the correspondence. These are the corresponding ones, and these are the ones opposite. So if we did what we did before, angle A would be equal to angle C. Angle E, which is up here, would correspond down here to angle D. And angle B, of course, is equal to angle B, the same angle. And so how would you do that? You might also say it's angle ABE is equal to angle, that's this one, ABE is CBD. And again, it doesn't matter, it could be DBC or CBD. So those are the angles. And then as far as sides, we have line segment EB, which is the small triangle on the left, matches up with DB. AB matches up with CB. That's this one right here and that one right there. And then the one that's opposite, those are going to be AE line segment matches up with line segment CD. Okay, so that's how those work with similar triangles. The next problem is 19. Find all the unknown angle measurements in each pair of similar triangles. So 19, we have those two little green triangles. And you can see that the angle, so let's just draw these out. So we've got the small triangle like this, a little bit of an angle like that, and the horizontal line there. And what I'm going to do is I'm going to group all these together. I'm going to clone it. And the nice thing about this is this basically scales it, so it's exactly the same triangle. And what we know is this is 28 degrees. This angle is 74 degrees. And I guess that's all we're talking about is angles. So in similar triangles, the angles are the same. So this is going to be 28 degrees. This will be 74 degrees. And because the sum of the angles in the triangle have to be 180, this unknown angle, which I'll call angle W, is just 180 minus 28 minus 74, which are the other two angles which we know. So 180 minus 24 minus 74, or 78, 28. Okay, sorry, I got something wrong here. 28. 180 minus 28 minus 74 is 78. So this angle here is 78 degrees. So it's also 78 degrees. And we have X, Y, Z, and TWV. So we can say that angle Y is equal to angle V, which is equal to 28 degrees. Angle X is equal to angle T, which is equal to 74 degrees. And angle Z is equal to angle W, which is 78 degrees. Okay, number 22. Similar kind of problem. Just got to figure out which angle goes with which thing. So let's see, I'll draw these. So we get the bigger triangle here. It's a right triangle, so let me go ahead and try to draw this as a right angle. Okay, so now what we'll do is we will create that. I'm going to clone it. I'm going to shrink it. And I'm going to rotate it. So it's something like, actually it's got to be something like, actually I got to flip it, I think. There we go. Okay, so you see I just changed the size of it. I didn't change the relative dimensions. So this is 90 degrees. this is one angle, which is 38 degrees. And this is the right angle again. So these two correspond. This angle here is 38 degrees because they show the sweep. So 38 plus 90 is 128. So this angle here is going to be 180 minus 128, which is equal to 52 degrees. So this one's 52. So this is 52, and this is 90. So what we can say is angle P is equal to angle P, not angle B. Angle P, which is over here, is also 38 degrees. And then we have angle X and angle M. Which is equal to 52 degrees. And of course these are 90 degrees. Okay, we'll do one more in this group, and then or one more in this video, and then we'll go to the next one. So we have 25 next. Find the unknown side lengths of each pair of similar triangles. Okay, so let's draw our triangle. And it's an isosceles triangle. Try to make it as isosceles looking as I can. So there it is. This side is 12, this side is 12, this side is 15. Okay, let me undo that. I need to group these things first. Okay, now I can write some numbers on it. So we have 12, 12, 15, 6, B, and A. So what happens is that the ratio of the two sides remains the same. So the ratio is going to be 12 divided by 6, based on this thing here. So all we have to do is take the corresponding sides. So we have 12 divided by A for here. Well, A, of course, is going to be 6, because they're just the same. So you put 6 in there. So A would be 6. And do the same thing. 12 over 6 is equal to 15 divided by B. So how do we solve for that? Well, this is actually 2, so we get 2 divided by 1 is equal to 15 divided by B, because we divide both by 6. And if we do cross multiplication, we get 2B is equal to 15, where B is equal to 15 halves. So that's the answer for B. So all we had to do is find this ratio. If we knew one of the ratios, then we knew all of the ratios.